engineering in 2013. His area of specialization is battery net theory and research interest in network optimization and graph theory. He has qualified GATE 2005 in mathematics. He has been awarded Young Scientist Award in 2017. He has published more than 40 papers in reputed journals. He is the member of expert committee of many national and international journals of repute. He has also completed 2 projects funded by JNU and SERB DST. One project is ongoing, which is funded by SERB DST. He is the nodal officer of Ek Bharat, Shresth Bharat, JNU, and associate NCC officer. He completed pre-commission course from OTA Camp T. He was also awarded by ADG Delhi DT for Best ANO for his excellence performance. Sir, I welcome you and thank you very much for accepting our invitation. So once again, sir and madam, both of you, I welcome you in this conferences. Now, with this word, I would like to invite our session chairs to conduct the proceedings further. So,
thank you so much, Dr. Suneet Saxena, sir, for inviting us for hearing this session. To carry this session forward, I would like to invite Sekia for the presentation of the title, A New Approach to Ranking of Fuzzy Numbers Using Mean, Area and Parameter. She is here, I hope.
Hello, am I audible, ma'am?
Yes, we can hear you.
Yes. Let's share my screen.
Okay.
Is my screen is visible, ma'am?
Yes, it is all right. Yeah.
Good morning, respected sir, madam, and my dear colleagues. I am Sunaina Saikia, a research scholar of Department of Mathematics, Cotton University. Today I am going to present my paper, which is on a new approach to ranking of fuzzy numbers using mean, area, and perimeter. These are some contents, which is abstract, introduction, definition, and the proposed method, a comparative study, application, and conclusion. Abstract, due to imprecise measurement techniques, method, and situation, uncertainty exists in several real-world applications. Fuzzy set theory is useful to controlling this kind of uncertainty in real situation. So, thus, in this paper, a new method of ranking fuzzy numbers has been proposed based on 3 factors, which are mean, area, perimeter of the fuzzy numbers. Further, some numerical examples are also discussed, which highlight the strong discrimination power of some well-established method, and furthermore, a real-life application is being discussed. These are some introduction. In 1976, Jane first published the ranking fuzzy numbers using maximizing set. Wang and Carey suggested some relevant conditions for establish the rationality validation of the fuzzy numbers ranking approach. Sen used the distance of the centroid point method to rank fuzzy numbers, while Yager used the centroid index method. Sen et al. Introduced a ranking algorithm for generalized fuzzy integers with varied left and right height. Then Sutia and also introduced the concept of decision level and a novel parameter form of fuzzy numbers which defuzzifies at varying heights. And at the recent, Patra proposed a method of ranking fuzzy numbers by using mean, area, and perimeter of a fuzzy number. Now, These are some definitions. Let's first discuss about how fuzzy numbers comes. So in real world, uncertainty is a prevalent phenomenon. So mass of the information on which decision making are based in uncertainty. Human decision making usually deal with making a decision in presence of vague, incomplete, or imprecise information, such as an example, Rajiv travel time from office to home about 1 hour usually. She is beautiful, he is tall. This kind of linguistic term usually somehow may be beautiful, tall, about, near, etc., whose meanings are not really clear. That's why the fuzzy comes. This type of information is represented by fuzzy set, which assign grades of membership to objects within their universe of discourse. In 1965, Zadeh first published a paper on fuzzy set theory. Now, what is the difference between classical set and fuzzy set? Classical set is about a number which is in the set or not in the set. That means a number is belong to the set or not belongs to the set. That means we answer the conclusion is about yes or no. That means 0 or 1. The this type of function that describe this is called fuzzy classical set. But a fuzzy set is one which assign grade of membership between 0 and 1. That means a interval between 0 and 1 to objects within each universe of discourse. If X is the universal set whose elements are X, then a fuzzy set A is defined as by mu A from X to interval 0 to 1, which assigned to every X a degree of membership mu A in the interval. Then what is fuzzy number? A fuzzy number A is the fuzzy subset of real line R such that f of A from R to the interval 0 to omega which satisfies the following properties. These are the properties where fa is upper semi-continuous, fa is equal to 0 outside the interval AD. There are real number B and C such that A less than equal to B less than equal to C and less than equal to D, and fa is monotonic increasing on AB, fa is monotonic decreasing on the interval CD, fa is equal to omega when X in between B and C. This is the definition of generalized fuzzy number. Generalized fuzzy numbers where in this fuzzy set a height is in the set. Now this is the definition of generalized fuzzy numbers. A, B, C, D, omega is described as any fuzzy set in the real line with membership function fa, where fa is described like this, where omega in between 0 to 1. If omega is equal to 1, then the fuzzy number is called the normal trapezoidal fuzzy number, and the condition is B is equal to C, then it is called normal triangular fuzzy numbers. These are the inverse function of FAL and FAR, and this is the inverse of the image of the fuzzy numbers. And these are some arithmetic of the fuzzy numbers, that is addition A plus B, and this subtraction A minus B, and this multiplication A into B, division of two fuzzy numbers A divide B is like this, and the scalar multiplication of a fuzzy number like this. Now coming to the point, our proposed method. The proposed method is based on the three terms, which is mean, area, and perimeter of a fuzzy number, and the mean of the fuzzy number is ma is equal to 1 by 4 into a plus b plus c plus d, and area is half into base into height, and the perimeter is defined as c1 minus b1 plus d1 minus a1 plus square root of a1 minus b1 whole square plus omega a square plus square root of c1 minus d1 whole square plus omega a square. Now the ranking index is defined as RA is equal to MA plus theta into 1 minus area divided by maximum of area plus 1 into 1 plus perimeter, maximum of perimeter plus 1, where theta is 1 if MA is greater than equal to 0 and minus 1 if MA is less than 0, where AIs are the fuzzy numbers. Now, depend on the ranking in this RA, the ordering of these fuzzy numbers is defined as RA is greater than RB, then we can say that A is greater than B. RA is less than B, then we say that A is less than B, and if RA is equal to RB, then we say that A is similar to B. The ranking of this array follows the ordering. A less than greater than equal to B if and only if A is greater than B, or A similar B, or and A less than equal to B if and only if A less than B or A similar to B. Now we prove some theorems by apply the proposed method. These are the theorems and these are corollary. Now we compare our proposed method with some well-established method. We take two fuzzy numbers A and B, and now we comparing these two fuzzy number. Then we get that our proposed method is give the similar to the method by Sen and Sen Nasri and Sutia and Avaswande and Hazari, but Rezvani and Patra give the different result, and also the other method cannot rank this fuzzy number. That's why we get a strong discrimination power of our proposed method, that our method rank these fuzzy numbers very well, but some other methods cannot rank these fuzzy numbers. Similarly, we take a second example, and where we get that our proposed method is similar to all other methods except Patra. Similarly, we get an third example, and where we get that our proposed method and the method by Nasri, Avaswande and Sutia get the similar result, but the other method either cannot rank the fuzzy numbers or give the similar fuzzy numbers, as well as that a recent paper research method that Patra, which also cannot rank these fuzzy numbers, but our proposed method can rank this fuzzy number, and which is a strong discrimination power of our proposed method. Now we take an application, a real life application. This is the methodology of these applications that constitute a committee of decision makers. Suppose that where there are some decision makers and some alternatives and some criteria, and we construct a decision. First step is we construct a decision matrix of each criteria based on the decision makers' opinions and on the alternatives and the appropriate linguistic variable of the rating provided the decision makers. Hence, the decision matrix decision matrix is this DS where alternatives with respect to decision makers. Hence, on the basis of this opinion, we calculate the arithmetics of. Okay.
corresponding आता है लिखा है ना प्लीज पुराना नाम क्या है
Yes, sir.
ऑथर का नाम और ये पुराना नाम है नया नहीं था उसका
You carry on.
Okay. Now we calculating the average of these opinions, and we take this average by these equations. Similarly, we construct a decision matrix of the weight based on the decision maker's opinion, and we get the average by these equations. And after that, in the selection problem, the aggregate fuzzy ranking of the alternatives, we get this matrix and evaluate the fuzzy numbers by the alternatives with this formula as they like this example, and finally we rank the fuzzy numbers by our proposed method. Here a real life applications we applied by this methodology. Let us assume that a university or college is looking to hire an assistant professor for the specific field. After initial screening, 5 candidates are led to further consideration A1, A2, A3, and A5. To conduct the interview and pick the best acceptable candidate, a committee of 5 decision makers or expert D1, D2, D3, and D4 has been constituted. 7 criteria are here, and these are the academic performance, subject knowledge, teaching aptitude, research experience, leadership quality, personality, and management capacity. And these are some linguistic variables which we considered to rate these alternatives. And these are the linguistic variables: very poor, fair, good, very good, and very low, low, medium, high, and very high. These are the linguistic variables, and we take some corresponding fuzzy numbers uh, about this linguistic variable. Now we constitute a decision matrices. These are the criteria C1, C1, C2, C7, and these are the candidates, and these are the decision makers. We take these candidates, decision makers, uh, linguistic term as like this: fair, good, and we take the average of these fuzzy numbers like this. By this exam, um, by these equations, we take the average of this linguistic term, and after that we also constitute a matrices which is criteria by decision makers, and also we take the linguistic term as very high, and like this.
Sorry to
And
intervene,
we
Sunaina. You have one more
okay,
minute to compile.
okay, ma'am, okay, ma'am. And we take the average of this linguistic term, and after that we multiplied both the matrices with these equations, and with after all we get some fuzzy numbers according to the candidates. And after that, finally we rank these fuzzy numbers by our proposed method, and we get that the candidates in order A4, A5, A3, A2, A1, where the A4 is the highest high expert agreed candidates. A4 is the most preferred of the candidates. Then we get the A4 is the most preferred among all the candidates. Okay. Now the conclusion. In this paper, a novel ranking method based on the mean area and perimeter of the fuzzy number, a number theta, is also introduced in this study. The proposed method provides a strong discrimination power, can efficient rank fuzzy numbers, which is evident from the numerical examples. Further, the proposed method was employed in the selection process of a post at an institute. Even though we obtain the candidate A4 is the most preferred among all the candidates. Furthermore, in this paper can be extended to study the ranking of intersectionistic fuzzy number into type 2 fuzzy numbers, single valued fuzzy numbers, and other forms of fuzzy numbers. These are some references. Thank you, ma'am.
Thank you so much, Sunaina.
Thank you, ma'am.
Is there anyone who just want to ask any question to Sunaina? You can write in your chat box, or you can just ask directly. I cannot see any question in the chat box. So thank you so much, Sunaina.
Thank you, ma'am. Thank you.
I just want to ask one question, that you have shown your A5 is the most effective point in your slide, but I could see in that same slide the table is saying that A5 is not, but A5 is the most effective. A4 is. Can we show the table again?
Okay.
The next, before that. Yes. Can you explain this A4? Because we can see here 5.3880 and 5.8308. But
Okay.
as you say that A4 is the most effective, can you little bit explain this order?
Okay, yeah,
How
yes,
did you
ma'am.
get
But
this?
yeah,
Yeah.
but we cannot say that by seeing these fuzzy numbers that this is the highest one, because there is the interval. So we cannot say that this is the highest. That's why we calculate by our proposed method. We cannot say by seeing
Okay.
that a fuzzy number is greater by the others.
Okay. So have you have calculated at your own by not by this?
Yes, yes, because we get these fuzzy numbers, and after we get these fuzzy numbers, we applied our proposed method by these
Okay.
fuzzy numbers.
Okay.
Then we get that A4 is the highest. We
Highest.
cannot say by saying that it is the highest one.
Okay. Okay. So thank you so
Okay.
much,
Okay.
Sunana, for
Okay.
this wonderful
Okay.
talk.
Thank you, ma'am. Thank you.
Now, can I call upon the Madiha Munir, Abdesh Kumar, and A.K. Srivastava for the presentation titled Carton Space with the Slope Metric under Edge Metrical Deconnection. Any of are here? If you are present here, you can just write down your name in the chat box. We can check it from here. Or
Madam, submission ID is 7. Paper ID is 7.
yes, this is paper ID 7. I cannot see in
Mm,
the meeting actually. He's not present. I hope any of.
okay, let's move to next.
Yeah, let's go to
Paper
the
ID 11.
next. Paper ID 11. This is Khushbu Antala and Sudhir Singh Sangha. Admission control for signal server trail queue with the backdown and wicking.
Yes, ma'am.
Khushbu is here.
Yes, ma'am. Are
Yes,
you
let's
audible, ma'am?
continue. Yes, you
Okay.
are audible.
Yes, madam.
Can you see my screen, ma'am?
Yes, Khushbu, we can see.
Okay. Myself, Pushpo Antara. I am from NIT Surat, Department of Mathematics and Humanity. My my presentation topic is admission control for single server retrial queue with the barking and breakdown. Now, outline of this course is introduction, model description, numerical result, conclusion, and references. Now, come to the introduction. These features are used in my presentation. The first definition is the retrial queue. Customer arriving in the system and see that the service facility become full, then customer has a two option. First, the some customer are leave the system, means that means it's a impatient customer, and some other customer are going to the orbit, and after some time he retrieve for the service facility and serve the get the service and leave the system forever. Is behavior of this customer is known as the retrial queue. This behavior is the retrial queue. Now, real life example of the retrial queue is see in many places like a shopping mall center, railway ticket counter, etc. Now, next is the barking. Barking is an arriving customer observe the queue length and decide to not join the queue. This behavior is known as a barking. Barking is example of barking is post office counter, railway ticket counter. Now next is the F policy. The number of customer in the system reached to its full capacity, though no further customer allowed to enter the system until the number of customer again drop to the prefix threshold value F. Example of F policy is the In a factory, all the incoming raw material handled by one machine. Due to the space limitation, incoming raw material are not allowed to enter the system when system capacity is full. Until the current stock raw material falls certain threshold value F, arriving raw material are allowed to enter the system. This we now come to the model description. Now we use the NT and YT. NT is the number of customer in the system at a time T, and YT is the status of the server at a time T. And YT defined like this: 0, 1, 2 up to 6. 0 is the server service is busy and arrive are forced to join orbit, same as the one is service is busy and arrival are allowed to enter the system. Two is the not enter the system. Server is broken down. Server is broken down during the primary repair phase, secondary repair phase, and five is the using the F policy, and six is the using the F policy, and customer are not allowed to enter in a secondary repair phase. Now model description, continue the model description. Customer arrive in the system as a poison process with the rate lambda and single server. We have explored the model MM1K using the backing breakdown, retrial queue, and F policy. The now customer arrive as a Poisson process with rate lambdas in a single server by follow the exponential distribution with the rate mu. If arriving customer are find the service is busy, then customer decide to join the orbit, and orbit has a finite capacity. After some time, customer retry from for the orbit get the service facility, and the orbit has a follow the Poisson distribution with the mean 1 upon gamma. In case the arriving customer finds the service is free, then immediately get the service and leave the system forever. When system capacity become full, then we require the setup job to stop the customer from joining the system. Then time to the setup job follow the exponential distribution with rate epsilon. Once the system capacity is full, then customer are not allowed to enter the system until the number of customer in the system to a threshold value F. Threshold level F. It assumes that the server requires the setup startup time with the mean 1 upon theta before allowing the customer in the system. The number of customer in the system drops to F level. The customer are served during the F policy with the exponential distribution with mean 1 upon mu 0. The server may break down at any time. Server breakdown generates with the Poisson process with rate alpha, एंड सर्वर कभी भी ब्रेक डाउन हो सकता है, तो उसके लिए हम उसको पॉइजन प्रोसेस विथ रेट अल्फा से जाएगा, और व्हेन server is break down, it cannot be repaired until the number of customer accumulate to a threshold value q. If broke down, server sent to a repair facility where the primary repair job is following by exponential distribution with 1 upon beta 1. After getting the primary repair, the server recover with the probability sigma. Otherwise, the broken down server goes to the secondary repair phase with the probability sigma bar, and the repair is done by a same repair man immediately get after primary repair phase according to exponential distribution with rate beta 2. Now, using this model description, we have governing the equation. We construct the steady state system for the state of a 7 level where yt is equal to I, where I varies from 0 to 6. Same as we can the following equation for a system state I is equal to 0, I is equal to 1 up to I is equal to 6. And now performance measure. Performance measure are derived using the governor equation. We can use the numerical method, which is a Gauss-Seidel method, and solve this all the equation, and we can find the performance measure. Is application of this model is this: expected number of customer in the system is defined as ENS. Here n is the number of customer in the orbit, O for the orbit, and n plus 1 is the number of customer in system plus one customer in the server and other n customer in the queue. That means here is the n plus 1 and here is same as the n plus 1. Expected number of customer in the system. Here is the expected number of customer in the Q and retrial orbit is following equation 19A and 19B, same as the system throughput is obtaining using throughput means customer live in the system is nothing but the throughput. Here throughput, customer live in the system with the rate mu and mu 0. During the F policy, the rate is mu 0 and other rate is the mu and multiply by its probability. The probability of the server being ideal and busy respectively. Ideal means server is free and busy. Server is free with the probability and defined as the server is busy. The probability that the server is broken down state and the waiting for the repair is the equation number 22. Now we define the numerical result. We set some default parameter like system capacity is fixed, k is equal to 6 and f is the 3. F is nothing but the F policy. Lambda is the arrival rate, mu is the departure rate, same as mu 0 is the during the F policy departure rate. Gamma is the customer are going to the orbit is the gamma, and theta beta 1 beta 2 is the server breakdown with the rate beta 1 and beta 2. Sigma is the probability, alpha is the failure rate. Now we see that the if server is increase means mu rate mu is increased, then and we take the different probability like 0.6, 0.3, 0.6 and 0.8. We get the number of expected number of customer in queue in the or retrial orbit and throughput and ff. Then is the system is good system, that mean के कस्टमर को यहाँ पर वेट नहीं करना पड़ेगा, सर्वर को हम इंक्रीज करेंगे और क्यू भी जनरेट कम होगी. और यहाँ पर हमने अराइवल रेट मीन्स कि लैम्बडा को मैंने वेरी करवाया और सर्विस को मैंने फिक्स कर दिया. लैम्बडा को मीन्स कस्टमर को मैं यहाँ पर इंक्रीज करवा रही हूँ. सपोज फर्स्ट प्रोबेबिलिटी 0.3 पे 246 आ रहा है, फिर 0.6 पे 246, देन हर टाइम पर कस्टमर इंक्रीज हो गए. दैट मीन क्यू कभी कंप्लीट ही नहीं हो, मतलब इन क्यू कभी स्टॉप ही नहीं होगी. दैट मीन कस्टमर यहाँ पर वेटिंग टाइम भी कस्टमर को ज़्यादा लगेगा और सिस्टम भी इनकम्प्लीट होगी, कभी खत्म ही नहीं होगी. Same as the arrival rate with theta and gamma. Then this you see this graph, if where ENS is the number of customer in the system and lambda is the number of lambda is the arrival rate. Arrival rate increase, the number of expected number of customer in the system will be increased, and here is the departure rate will be increased, the number of customer in the system will be decreased. You can see this figure. Now conclusion of this presentation is, we have the investigate the performance analysis of a controlled F policy for a MM1K model with the retrial orbit, server breakdown and backing. We explored the investigation queuing model. We analyzed the effect of a system parameter lambda, mu, theta, gamma on different parameter indicates. The model may be extended including the renaging of the customer. References is I have used these references. Thank you.
Thank you, Khushbu.
Welcome.
Is there any question from the participant? I cannot see any question in the chat box, so I think it was good, wonderful presentation by Khushbu. Let's invite the other submission ID number 12. So it's Shivani Sundrial and Jaya Upreti. Can we have both of you here?
Yes, ma'am.
Yeah, so please.
Okay, I'm. Good afternoon to all of you. Myself, Shivani Sundrial. I am a research scholar in SSJ campus, Almora, Kumar University, Nainital, under the supervision of Professor Jaya Upreti. Today I am presenting my research paper, which is entitled as Soliton on Parasasakian Manifold with respect to the Schouten-Van Kampen connection. So the abstract is, the purpose of this presented paper is to study some soliton types on Parasasakian manifold for which the Ricci soliton is steady, shrinking or expanding. We also discuss the geometrical properties of Ricci soliton and Yamabe soliton. Also, we have studied the curvature properties of Schouten-Van Kampen connection on the n-dimensional Parasasakian manifold. So first of all, what is the introduction part is the concept of almost para contact manifold was introduced by I. Sato, who further drew some of its special cases and recognized as Parasasakian and spatial Parasasakian manifold. Further that there we many geometers introduced many conditions on these Sasakian manifolds and get different type of Sasakian manifolds like Lorentzian Parasasakian manifold and spatial Parasasakian manifold and many other. Next, the geometrical properties of Parasasakian manifold have been extensively studied by several authors such as Sasaki, Shukla, Mandal, Ucide, Ildiz, and many others, recognized as Parasasakian. Next, the connection I have been used is the Schouten-Van Kampen connection, which is one of the most natural connection. It is a pair of complementary distributions on differentiable manifold bearing an affine connection. Then the Ricci flow was first introduced by Hamilton. He get the canonical metric on smooth manifolds, and the study of the manifold with positive curvature become the easier after the introduction of Ricci flow. A Riemannian metric G on a Riemannian manifold M of n dimension is called an almost Ricci soliton if one can complete vector field Y on M that satisfy the following equation. That this is the equation number 1, where L is the Lie derivative with respect to the Levi-Civita connection, S is Ricci curvature, and G is Riemannian metric. Here, alpha is the constant which defines the about the soliton if it is shrinking, expanding, or steady. If value of lambda is less than 0, then it is shrinking. If it is greater than 0, then it is expanding. Or if it is equals to 0, then it is a steady Ricci soliton. A Riemannian manifold M with Riemannian metric G is called eta Ricci soliton if there occurs a smooth vector field Y such that it get this equation number 2. In this equation, the other terms are same as the almost Ricci soliton. The extra term have been added is eta term. So it is a tuple type of Ricci soliton. Now, next, a triplet GY gamma is called an almost Yamabe soliton on a Riemannian manifold MG if it satisfies equation number 3. The initials are same. L is Lie derivative, G is Riemannian metric, and gamma is a constant which defines the expanding, steady, or shrinking property of this soliton. Now, we have used their Parasasakian manifold. So first, what is the Parasasakian manifold? Any n-dimensional manifold M is said to be an almost para-contact manifold if it admits this triplet phi, xi, and eta. These are the conditions for this triplet given by an equation number 4, and a compatible Riemannian metric with this triplet will satisfy equation number 5 and 6. So then an n-dimensional, this is the definition of almost para-contact manifold. We said almost para-contact manifold, a Parasasakian manifold, if it satisfies this additional condition, equation number 7, which is given in equation number 7. Also, a Parasasakian manifold satisfy equation number 8 with respect where nebula is the Levi-Civita defined as the Levi-Civita connection for the Riemannian metric G. For n-dimensional Parasasakian manifold, the Ricci tensor S and Ricci operator Q all satisfy these equations. We have been used these equations throughout this paper. Now, an n-dimensional almost para-contact Riemannian manifold M is said to be an eta Einstein manifold if the Ricci tensor S satisfy this condition. Here, A and B are two smooth functions on the manifold. In particular, if B is 0, then it is called on just Einstein manifold. Now, the next term is the Schouten-Van Kampen connection we have used in this research paper. The Schouten connection, it is denoted by tilde nebula on the almost para-contact manifold with respect to the Levi-Civita connection nebula is defined by equation number 11. We have calculated this value for particular manifold, para-Sasakian manifold. The metric G vector field Xi and one form eta are parallel with respect to this connection. So that's why the values of this these differentials, we get zero values, and the torsion tensor is not equals to zero value, and it is defined by this equation. Now, the first result we found in this paper is the para-Sasakian manifold with respect to the Schouten-Van Kampen connection. We have find this equation number 12 for para-Sasakian manifold, which is applied in the Schouten-Van Kampen connection. Also, it satisfies this equation number 13. We have also calculated the value of curvature tensor with respect to the Schouten-Van Kampen connection, which is given by in equation number 14. And the Ricci curvature with respect to the Schouten-Van connection is given by equation number 15.
Sorry
the value of
sorry to intervene.
Yes, ma'am.
You have many slides, 24 slides I can see. Just keep in mind you have 10 minutes for presentation. You have already consumed your 6 to 7 minutes, so you have 3 minutes left. Okay.
Yes, ma'am. I will. Yes, ma'am. I am doing in that way, and I am Shivani Sundariyal, not Javapriti. She is my guide.
Okay.
Yes. Yes, ma'am. The Ricci operator and the scalar curvature are given by equation number 16 and 17. The main results of my research paper are this in the further slides. In theorem of 1, we get an n-dimensional para-Sasakian manifold M is an Einstein manifold with respect to the Schouten-Van Kampen connection if and only if M admits a Ricci soliton Xi, alpha, and G with respect to the Schouten-Van Kampen connection. The proof of this theorem is given by these slides. I think I don't have to explain the proof. In theorem number 2, we get on an n-dimensional para-Sasakian manifold, an almost Ricci soliton is always steady with respect to the Schouten-Van Kampen connection. In this conclusion, we get the value of alpha is always 0 for this n-dimensional para-Sasakian manifold when it attains the Schouten-Van Kampen connection. The proof of this theorem is this. In the next theorem, the scalar curvature of an n-dimensional para-Sasakian manifold having an almost Ricci soliton with respect to the Schouten-Van Kampen connection is given by this value, where R is the negative value of alpha M. In result 4, let M be an n-dimensional para-Sasakian manifold admitting an eta Ricci soliton. Then M will be an eta Einstein manifold with respect to the Schouten-Van Kampen connection, and the proof of this theorem is in this slide. Next is next result is on the Yamabe soliton. A Yamabe soliton, this is a tuple on n-dimensional para-Sasakian manifold. It is invariant with respect to the Schouten-Van connection if this condition is satisfied, that is n minus 1 plus trace of phi square equals to 0. The proof of this theorem is this. In the next theorem, let M be an n-dimensional para-Sasakian manifold admitting an almost Yamabe solution with respect to the Schouten-Van Kampen connection. The scalar curvature R of M is equal to the gamma if and only if Y and Xi are pairwise collinear in this manifold. So the proof of this theorem is this. And from this theorem, we also get two corollaries. The first one is an n-dimensional para-Sasakian manifold M admitting a Yamabe soliton with respect to the Schouten connection is of constant curvature with respect to the Schouten-Van Kampen connection if Y is pointwise collinear with Xi. The next corollary is if an n-dimensional para-Sasakian manifold M admits a Yamabe soliton with respect to the Schouten-Van Kampen connection and Y is pointwise collinear with Xi, then the Riemannian metric G is Yamabe metric for the manifold M. So I have concluded all this, and the references I have been used in this paper are this. Thank you. Any question? I have completed my PPT, ma'am.
Okay. Thank you, Shivani. Is there any question from the participants? So it was a wonderful presentation by Shivani. Now we call upon Diksha Bhardwaj and Dinesh Tripathi for the submission ID number 13 for the presentation.
Thank you so
Ye-
much. Thank you
Yes,
so much.
ma'am. Good afternoon, ma'am. Am I audible?
Yes, yes, Diksha.
Okay, let me share my screen. Ma'am, is my presentation visible?
Yes.
Okay. So, good afternoon, everybody. My name is Diksha Bhardwaj. I am a PhD scholar at the Department of Mathematics, Manav Rachna University, under the guidance of Dr. Dinesh Tripathi. And the title of my paper is Number of Zeros of a Polynomial in a Disk. To see at the abstract in this paper, we will use restrictions on the coefficients of a complex polynomial to obtain the number of zeros inside a disk in the complex plane. This is the content. So initially, we know that there is a vast amount of research being done on the location of zeros of a polynomial. Uh, in, at the start, Gauss and Cauchy provided some results to give the location of zeros of a polynomial, and then using those results, Instrom and Kakea provided us a very famous result which gave us the location of zeros of a polynomial inside a unit disk, imposing monotonicity conditions on the coefficients. So using similar monotonicity conditions on the coefficients in this paper, we will find the number of zeros of the polynomials. This is the result provided by Unstrom and Kakea, in which it says that all the zeros of a complex polynomial having non-negative monotonically increasing real coefficients lie inside a unit disk. Extending this result, Joel and Nabel removed the non-negative conditions to provide the location, to see that the location of zeros changes. It is not the unit disk but some other disk in the complex plane. So now we have talked about the location of zeros of a polynomial. So Titmarsh provided us this result for the number of zeros of a polynomial, where it says that if f is an analytic function satisfying some conditions, then the number of zeros lying inside inside a disk will be less than this number, 1 upon log 1 by lambda log m upon mod f naught. Using this result by Titmarsh and the monotonic conditions by Instrom and Kakea, many mathematicians have provided us many extensions of these results, such as this given by Mohammed, where he has applied the monotonic condition on the coefficient and the result by Titmarsh to see that the number of zeros of a complex polynomial lying inside mod z less than equals to 1 by 2 has this bound. Diwan and Pukta further generalized this result by Muhammad to give us some better bounds of the polynomials, better bounds for the zeros of a polynomial. And recently, Robert Gardner and Brett Shields had imposed monotonicity flips on the real and imaginary part for at the position R and S, providing us the following result, where we can see that the real part of the coefficient alpha k's have monotonicity flip at R, and the imaginary part of beta k's have monotonicity flip at the position S. And using the result by Titmarsh, we see that they have provided us the number of zeros of a polynomial, this where B has this value given by this value here. So using this result, we will further apply some similar restrictions on the coefficients and give some better bounds for the zeros of the polynomials. So here are the main results. Here you can see, similar to the result given by Robert Gardner and Brett Shields, I have applied some different conditions on the real and imaginary parts of the coefficient to find some different bounds for the number of zeros of a polynomial. And if in this theorem we take t equals to 1 and the points where the flips were taken to be 0, we get this following corollary, where we see that alpha n's are monotonically decreasing and beta i's are monotonically increasing, and then we get this bound here, which is different from the one in the theorem. Similarly, if we take the monotonic flips at n, we get different bounds for the polynomial. Now, this is the next theorem where I have taken a different combination of monotonic flips where, in the real and imaginary part, and we have obtained the following better bound for the number of zeros of the polynomial. And similar to the previous corollaries, if we take the flips at 0, we get a different bound, and if we take the flips at n, we get the different bounds for the number of zeros of a polynomial. And these are the references for my paper. Thank you so much. Hello, ma'am, I have completed my
Yeah,
presentation.
thank you so much, Diksha, for your presentation. Is there any question from the participants? So I cannot see any question from the participants. So thank you so much, Diksha, for your wonderful presentation. Now I
Thank you so
can
much, ma'am.
call the next participant, next presenter. His ID number is 14. Uh,
Yes, ma'am. Am I audible?
yes, yes. Yeah, Vikas Verman and
Yes, ma'am.
Kukilkar. Yes, please, you continue.
Good afternoon, everyone. I am Vikas Burman, research scholar in the Department of Mathematics, Cotton University. I am pursuing my PhD degree under the guidance of Dr. Kokil Korporaskwa, sir. Today, I am going to present my paper, Intersection Minimal Ideal Graph. This is my outline for my presentation, abstract, literature review, result and discussion, and references. The abstract of my paper. In this work, we introduce and investigate the notion of intersection minimal ideal graph. For an Artinian ring, the intersection minimal ideal graph is denoted by wedge of R is a simple undirected graph whose vertices are proper non-zero ideals of the ring and two vertices I1 and I2 are adjacent if their intersection is a minimal ideal. In this article, we explore properties like connectedness, diameter, click number, planarity, cut vertex, independence number, etc. Basically, in this work, we try to establish the interdisciplinary relation between graph theoretic properties of our defined graph with the algebraic properties of the ring. These are some literature we have reviewed before preparing our work. In 1988, Ispan Vick opened up the enchanting perception which relates the graph with algebraic structure ring. He introduced the zero divisor graph of commutative ring. His idea was to let the vertices corresponds to the points of the ring R and the S corresponds to the relation that the products of the corresponding elements is zero. In 1964, Bosak defined the intersection graph of semigroup. He defined the graph taking the set of all semigroups of a group as the vertex set in which two vertices are adjacent if they have non-trivial intersection. That is, the intersection does not equal to 0. In 1995, comaximal graph of commutative ring is introduced by Sharma and Fatwendecker. They take the elements of the ring as the vertices and two elements A and B are adjacent if Ra plus Rb equal to the ring itself. In 2007, Syed Akbari and Babak investigate the comaximal graph of subgroup of a group. They define the graph with the vertices as the non-trivial subgroups of the group, where two distinct vertices H and K are adjacent if their semi-direct product is the group itself. In 2009, Chakrabarty, Ghosh, and Mukherjee defined the intersection graph of ideals of a ring. They investigated the Bosaks defining in rings, taking ideal as vertices. In 2017, Ibrahim Etani and Dolat Pishari introduced the small intersection graph. He takes vertices as the non-small ideals of the ring, as vertices, and two vertices I and J are adjacent if their intersection is non-small inner. So our defined graph looks like this in case of integer modulo 6. Clearly, it is a star graph. This star characteristics is present here due to the fact that the ideals of integer modulo 6 or integer modulo p to the power n forms a same. In case of ZP2 Q2, the graph look like this. It is a connected graph with diameter 2 and grid 3. The diameter is the maximum among the distances between every pair of vertices, and grid is the length of the smallest cycle present in the graph. Then we try to give some generalized result, and we prove this result by the method of contradiction, contrapositions, or by some examples and different principle of mathematical induction, etc. An ideal R is said to be minimal if does not contain any non-zero ideal, and we use mean of R to denote the set of all minimal ideals of R. The circle of a ring is the sum of all minimal ideals of the ring R. Now, in the first lemma, we established that every non-minimal ideal is adjacent to at least one of the minimal ideal of the ring. And soc of R is adjacent to every minimal ideal of the ring. In remark 1.2, we show that any two non-minimal ideals are non-adjacent since the intersection of two minimal ideals is 0. So the subgraph induced by the minimal ideal is empty. The neighborhood of a vertex is the collection of all vertices adjacent to the P. In theorem 1.3, we take three vertices P, Q, and N, where N is a minimal ideal and P intersection Q is not equal to N. Then N belongs to the neighborhood of P intersection Q if and only if N belongs to the neighborhood of P as well as neighborhood of Q. Then we establish that if an ideal contains the circle, then that particular ideal is neighborhood of every minimal ideal. In the next, we take an ideal which is not a minimal ideal and that ideal is contained in some other ideal Q. Then obviously P is not belongs to the neighborhood of Q. In the next result, we take two ideal which are we take two non-minimal ideal which are adjacent in our defined graph. Then there exists a unique minimal ideal which is adjacent to both M and N. The graph is said to be empty if it does not contain an edge. Now we try to give the property which gives the graphs to be empty. Every non-zero proper ideal of R contained in minimal ideal of R, that is every ideal is minimal, then the graph is empty. A graph is said to be connected if there exists a path between every two distinct vertices. Now in theorem 1.6, we established that the minimal intersection graph is connected if and only if sum of two distinct minimal ideals is not equal to the ring or number of minimal ideals present in the ring equal to 1. Next, so diameter is the maximum distance among all the distances between every pair of vertices. Now, in case of our defined graph, diameter is always less than equal to 4. The grid is the length of the smallest cycle present in the graph. In theorem 1.8, if
Please conclude your quickly in next 2 minutes.
yes, sir.
Please conclude in next 2 minutes.
Okay. In theorem 1.8, we established that if circle is not equal to the ring, then the grid of the graph will be equal to 3 or 4. Then the graph will be complete if it has exactly one minimal ideal. But the converse of the result is not true. In case of ZPN, we see that it has one minimal ideal, but the minimal intersection graph in case of ZPM is not complete. It is a star graph. If a chain is formed by the ideals of R, then the minimal intersection graph will be a star. Then in the next result, we establish that the graph will be complete bipartite if every ideals of R is either essential ideal or minimal ideal. In theorem 1.2, we establish that if the sum of two distinct minimal ideals of R is not equal to the ring and K is a cast vertex of the graph, then K must be equal to sum of two minimal ideals. A vertex is said to be cut vertex if removal of each makes the graph disconnected. In theorem 1.3, you establish that the clique of the graph is contained in the subgraph induced by the set P belongs to vertex set such that Q is subset of P. In the next result, we establish that if the graph, if Q belongs to mean of R and subgraph is induced by this set and is planar, then the clique number is less than equal to 4. If the graph is non-empty and vertex set is the collection of all minimal and maximal ideals, then the graph is a split. The graph is said to be split if it can be divided, if the vertex set can be divided into two parts such that one part is independent set and the other part is clique. If the vertex set contains all the minimals ideals and maximal ideals and number of maximal ideals is less than equal to 3, then the graph will be planar. If the number of minimal ideal is finite, then the independence number of the graph is equal to the number of minimal ideal present in the ring. Then these are the references I use for my works. And thank you.
Thank you, Vikas. Vikas, can you tell me what is the exact title of your talk? Because I can see in the data in our database that I received from Dr. Anju. The data is your title is intersection minimal ideal graph of an
Artinian ring.
Yeah. So here
Yes.
you have not added that term.
Because we are thinking of extending the work to a general ring. Previously,
My question is what title you want in the certificate?
In intersection minimal ideal graph of an Artinian ring.
Of an complete title you want there. Okay.
Yeah,
you want to print that name intersection minimal ideal graph of an Artinian ring, right?
Of an Artinian ring.
Yeah. So you must mention here if you are writing you want.
Yes.
Okay.
Yes, sir.
And can you tell me first fundamental question? What is the significance of this to relating the ideal concept to the graph theory?
Because if we study the interdisciplinary concept, it helps in understanding of both the branches of the mathematics. Here we relate the minimals ideals with graphs, so it gives us the picture how the minimal ideals and other ideals are related.
That's okay, but how will you use in our practical? Can you give 1 or 2 line answer? Because there are a lot of application that I know. I want to just listen from your end.
Sir, I have not prepared for this. I have to look forward for find the practical applications.
Okay, but what and have you published this work somewhere?
No. It is not published yet.
You are going to submit it?
Yes, sir.
Okay. Thank you.
Thank you, sir.
And welcome again to all the participants and Dr. Anju Kandelwalji. Namaskar, madam.
नमस्कार सर आई एम ज्वाइन हियर इन द स्टार्टिंग आपने देखा नहीं है इवन मुझे
Okay. Maybe I did. And okay.
प्लीज कंटिन्यू सर
After presentation. And the next presenter is, if there is no question, the next Arti Salat or Dr. Amit Sharma, who is going to present the next title, distinguishing.
Hello, sir. Am I audible?
You are audible. Yeah, you are Arti.
Yes, sir. I'm Arti Salat.
Okay. Now you can share your screen and present.
Okay, sir. Good afternoon, everyone. Myself, Arti Salat. I'm doing research in graph theory under the guidance of Dr. Amit Sharma. And today I'm going to give presentation on the distinguishing number of some different kind of graphs. This is the outline of the presentation. Now go to the abstract. So in the present study, the distinguishing number of some different graphs is focused where the different graphs like coconut tree graph, firecracker graph, jellyfish graph, triangular book graph, and banana tree graph. have been taken into the account. The major goal of the proposed study is to understand the distinguishing number of different graphs for better insights. It is evident from the results that the distinguishing numbers and automorphism groups of the above mentioned graph have been carried out successfully. The obtained result emphasizes that the distinguishing number of coconut tree graph is n, firecracker graph is n minus 1, triangular book graph is 3 if n is equal to 1, and it is n if n is greater than 1. For a jellyfish graph, it is 2 if n is equal to 1, and it is n if n is greater than 1, when m is equal to n. And when m is different from n, then it is maximum of m n. And finally, the banana tree graph is n minus 1 if m is less or equal to n minus 1, and it is m if m is greater than n minus 1. So first of all, we should know what is the distinguishing number and what is the motivation behind to finding a distinguishing number. So consider there is a one home and there are 5 doors in that home. So the question is arise, how can someone unlock the particular door without trying to wrong keys on the lock of the door? So this problem leads that what is the minimum number of colors or labels needed to uniquely identify exit key of particular door? So the answer is that if we give different colors or labels to the keys of every door, then we will be able to identify exit key of particular door. This problem was solved by Albertson and Collison in 1996, and they defined the distinguishing number of the graph. So the distinguishing number of graph G is the minimum number D such that there is no non-trivial automorphism of graph G preserves all of the vertex labels. For example, I have taken here path Pn. So we can see here the degree of V1 and the degree of Vn are same. So any non-trivial automorphism of Pn can be mapped V1 to Vn. And if it is maps V1 to Vn, then it has to map V2 to Vn minus 1, V3 to Vn minus 2, and so on. Because we know that the automorphism of graph G preserves the adjacency of the vertices. So here we have two possible automorphisms for Pn, which are, first one is the identity, and the second one, phi 2 of Vi is equal to Vn minus I plus 1 for every I between 1 to n. So that is just a flipping. So here we have seen that phi 2 can map Vi to Vn minus n minus I plus 1. So we have to assign the vertices Vi and Vn minus I plus 1 with the different labels. So we are assigning here Vi with the label 1 and Vn minus I plus 1 with the label 2. So we are getting this labeling. And we can see here the non-trivial automorphism phi 2 cannot preserve all of these vertex labels. So hence the distinguishing number for Pn is 2. Now some known results are available in the literature too. The distinguishing number for cycle Cn is 3, for n is equal to 3 for 5, and it is 2 for n is greater than or equal to 6. The distinguishing number for the wheel graph is 4 when n is equal to 4, and it is 3 when n is equal to 5, 6, and it is 2 when n is greater than or equal to 7. For the star graph, the distinguishing number is n for every n. And for the biped type graph, the distinguishing number is n plus 1 when n is greater than or equal to 4. A graph G with non-trivial automorphism has one distinguishing number. For a graph G, if the cardinality of the vertex set of G is same as the distinguishing number of G, then G is the complete graph, and it is also true in the converse. Further, some result related to distinguishing number of different graphs available in this literatures. These are the main definitions which we have used to obtain the results. Now the main objective of the present study is to find the distinguishing number of coconut tree graph, firecracker graph, jellyfish graph, triangular book graph, and the banana graph. As I told you, distinguishing number is based on the automorphism of the graph G, and the automorphism of graph G is the concept of the algebraic graph theory, and algebraic graph theory is the combination of graph theory and algebra. So we have used here graph theory and algebra as a methodologies, and we have used LaTeX and Beamer to making our presentation and the research paper. Now these are the main results. In the main results, we have derived 5 results. First theorem, the distinguishing number for a coconut tree graph is n. So let CTMN be a coconut tree graph obtained from a path PM by joining n pendant edges to the end vertex of PM. So our CTMN will be looks like this graph. So here we can see that the degree of U1, U2, U3, U4 up to UN is 1. And the neighbor of U1, U2 up to UN is VM. So any non-trivial automorphism of CTMN can be mapped these vertices to each other. So we have to assign U1, U2 up to UN with the different labels. So here we are assigning U1, U2, U3 up to UN with the labels 1, 2, 3 up to N respectively. And here we can see that V1, the degree of V1 is also 1, but the neighbor of V1 is V2. So if the automorphism of CTMN can map V1 to any one of the U1, U2 up to UN, then it has to map V2 to VM, but that is not possible because the degree of V2 is 2 and the degree of VM is N. So any non-trivial automorphism of CTMN can be will be fixed all of the vertices V1, V2 up to VM. So here we are assigning these vertices with the label 1. So this labeling is distinguishing. Hence, the distinguishing number for CTMN is 1. Now, next theorem. For a triangular book graph, the distinguishing number is 3 if n is equal to 1 and it is n if n is greater than 1. So let us take case 1 when n is equal to 1. So when n is equal to 1, then the triangular book graph will be the cycle graph. And we know that for the cycle graph C3, the distinguishing number is 3. So we are done. Now for the case 2, when n is greater than 1. So when n is greater than 1, then our triangular book graph will look like this. So here we can see that the degree of U1, U2 up to UN is 2. And the neighbors of U1, U2 up to UN are U and V. So any non-trivial automorphism of the triangular book graph can be mapped U1, U2 up to UN to each other independently. So again, we have to assign these vertices with the different labels. So we are assigning these vertices with the labels 1, 2, 3 up to N respectively. And again, also we can see that here, the degree of U and the degree of V is same. And the neighbors of U are same as the neighbor of V. So again, a non-trivial automorphism of B3N can be mapped U to V and V to U. So again, we have to assign U and V with the different labels. So we are assigning U and V with the labels 1, 2 respectively. So we are getting this labeling. And we can see that this labeling is distinguishing because any non-trivial automorphism of B3N cannot be preserved all of these vertices. Hence, the distinguishing number for B3N is N when N is greater than 1. Now, these are the other results which we have determined in the research papers. Theorem 3, the distinguishing number of a firecracker graph is N minus 1. Theorem 4, for a jellyfish graph, the distinguishing number is 2 if N is equal to 1 and it is N if N is greater than 1 in the case of M is equal to N. And the distinguishing number for a jellyfish graph is the maximum of Mn where M is different from N. And the last result for a banana...
Please conclude in next 1 minute. Okay.
Okay, sir. Yeah. Now go to the conclusion. The number of automorphism and automorphism group of some graphs like coconut tree graph, firecracker graph, jellyfish graph, triangular book graph, and banana tree graph have been determined Further, the distinguishing number of coconut tree graph, firecracker graph, jellyfish graph, triangular book graph, and the banana tree graph have been determined by the behavior of the automorphism of that graphs. Since the distinguishing index of the above mentioned graph are not determined in this paper, so the other researcher can be determined the distinguishing index of the above mentioned graphs. These are the references. Now, thank you so much.
Any questions from the audience? Let me check if any question in the chat box. No, there is no question in the chat box. And Aarti,
Yes, sir.
you are working on this distinguished graph
Distinguishing number. Yes, sir.
distinguished number. Last 1 year or 2 years?
No, sir. Actually, last 1 year.
Last 1 year. Have you published any article?
No, sir. No, sir. Actually, sir, my topic is the automorphism group of graphs, and this is the one of the topic of the automorphism of the graph. Means this is the labeling which depends on the automorphisms of the graph. Distinguishing labeling.
Topic is very good topic. Actually, there are a lot of scope in this to go in this direction. Not only the distinguished number graph number, but also other parameters, other name also available in the. So you must also try to get those papers. They have also some certain kind of applications in various areas. I
Yes,
have
sir.
also seen, because they basically based on some operation. Okay. And one
Yes,
more
sir.
things you have mentioned in your PPT, latex. Latex is not the technique you, okay. It is a scientific, some kind of typographical
Okay,
document.
sir.
And whenever you are citing some work, you must mention the references in between the PPTs. You have not mentioned okay in between. Although you have said this is a work then you have taken from some other work, but you have not mentioned. You must give some kind of reference, because if you are using latex, there is an option very easily the citing side command you can easily. Okay.
Okay, sir.
And thank you very much, Aarti.
Okay, sir. Thank you.
Without wasting time, I would like to call the next presenter, Anshul Dubey or Rajal Singh Ritikar. Who is going to present?
Anshul Dubey, sir.
Say again, please.
Hello, Anshul Dubey.
Anshul Dubey. Yeah, Anshul Dubey. Yeah, please share your screen and present.
Okay, thank you, sir. Hello, my name is Anshul Dubey and I am research scholar. Statistical analysis through the chi-square test in the reported cases of malaria at Muradabad in Uttar Pradesh. Second slide is represent abstract. In this research paper, statistical analysis on the reported cases of malaria disease at Muradabad in Uttar Pradesh. This paper uses the data of 8 blocks named Tajpur, Munda Pande, Bhojpur, Kant, Kundarki, Bilari, Thakurdara, Dilari, and Muradabad. Is reported. This test help detect the association between the years and the corresponding genders. The collected data is secondary and its unit in thousands and encompasses the 6 data points which spread from 2016 to 18. In this test, the experimental frequencies are equated with the expected or theoretical frequencies. If determined worth of the chi-square is not exactly the table worth, the specific degree of degree of importance and specific level of opportunity, the fit is viewed as great. That is, the disparity between the real and expected frequency is ascribed to variances of basic examining. Then again, if the determined worth of chi-square is more prominent than the table worth, fit is viewed as poor. Keywords: the secondary data includes the 8 blocks: mosquito infection, chi-square test, transmission, and treatments. Introduction: malaria is single of greatest prevalent transferable disease and is serious public health problem. The illness is spread through protozoa, parasites of Plasmodium genus. Malaria causes.
Also, please go to the main work that you are going to present in this.
Yes, sir.
Please go to the main work.
Ji?
Do not require to explain introduction part. Go to the main work that you are going to present.
Okay. Thank you, sir. इंट्रोडक्शन में सर बेसिकली हमने इसमें यही कहा है कि मलेरिया जो है वो कैसे फैलता है प्लाज्मोडियम जेनेस से. मलेरिया कॉसेज जो है इन्फेक्शन दैट क्लासिकली इंक्लूडिंग द टेम्परेचर, स्लीपनेस, अनसेटल्ड स्टोमक एंड हेडेक्स. In some cases, it can cause yellow skin, seizures, coma, or death. Symptoms usually begin 10 to 15 days after being bitten, and this disease is most commonly transmitted and infected female Anopheles mosquito. The mosquito bite introduces the parasite from the mosquito's saliva into a person's blood. The parasites level to liver via mature and reproduces. And next, the examples: perception out to be free, the requirement on the cell frequencies, if any, ought to be the straight, and loud, whatever the compresses, the hardness, and yet, and the erratic. We might say that n ought to be somewhere around 50, and however few the cells. Next, the chi-square test is one of the easiest and the broadest test known as apply the extremely enormous number of issues, particularly speaking, which can be summarized under the accompanying heads: as a trial of the integrity of fit, as a trial autonomous and quality, as a trial of homogeneity, of autonomous spiral of the populace difference, as a fit of hypothetical value of population variance sigma square. Then research methodology. The objectives are to statistically analyze the reported cases of malaria, its extent or treatment at Muradabad in Uttar Pradesh. The following research methodology is introduced for purpose: research paper, identification of research problem of malaria patient, hypothetical framework and study, to related writing of malaria patients, numerical formulation of examination issues to break down of arrangement of related instances of malaria patient 2016 to 18 to find the association between two or more attributes. Then interpretation and statistical analysis through the chi-square test or results. Conclusion and recommendation. Mathematical formulation of research problem. Let us an n cross m contingency table, OIJ observed frequency of ith and jth cells. EIG expected frequencies of OIJ is equal to EOIJ equal to EAI and B. Thus, using H naught hypothesis such that OIJ is equal to EIJ attributes are independent. Then the formulation chi-square is equal to double summation OIJ minus EIJ ka whole square divided by EIJ and n-1 m-1 degree of freedom, where I is values and J values. OIJ null hypothesis Oij is equal to Eij, and the alternative hypothesis H1 Oij greater than Eij. Then chi-square the double summation Oij minus Eij ka whole square upon Eij, then n minus 1 m minus 1 degree of freedom. Decision rule: if chi-square calculated value less than and equal to chi-square 5% level per, hypothesis is accepted against H1 at 5% level of significance. Chi-square calculated value is greater than of tabulated value. H0 is rejected in favor of H1 at 5% level of significance. Thus, attributes are not independent. Then, collection and data presentation. The data required for this study are monthly reported cases of malaria. It covers 2016 to 2018 with a total 6 points, and the 8 blocks in Muradabad were chosen for research paper. The data presented in table 1 show the 6 months of reported cases of malaria within 3 years, 2016 to 2018. A close look of Table 1, observed value of malaria from 2016 to 18. In this table, years 2016-18, male and female, and the total. Next one, Table 2, expected values of malaria from 2016 to 18. Then, calculation, we have to first calculate the expected values of observed frequency. These are shown below. Next slide. The degree of freedom is 3 minus 1 and 2 minus 1, then 2. The critical value of chi-square for degree of freedom at 5% level of significance is 5.991. Conclusion, let us take the following hypothesis. Null hypothesis: there is no relationship between genders and preference of the ear. And alternate hypothesis: there is a relationship between genders and preference for ears. Since the calculated value of chi-square is equal to 0.5325, does not exceed the critical value of chi-square. Thus, the null hypothesis is acknowledged. Consequently, the end is that there is no connection between the gender and preference the ear. Then, acknowledgement and recommendation for these findings: it is very clear that humans become infected with the malaria through the mosquito bites. It is recommended here that precautions should be taken to prevent mosquito bites as well as reduce the mosquito exposure and insecticide outdoors and in sleeping areas. Then these are the references, and thank you.
Anshul Dubey.
Ji, sir.
Okay. So you have used chi-square technique. Why
Yes.
why you have chosen this test? Why not other tests? Because we have also other tests. Those are able to predict a better result.
But sir, it is for good for best fit the two attributes.
Other tests also there. They are more
Yes,
efficient.
sir. Yes, sir.
Why you have chosen, and because that in the conclusion you have suggested something, so that is already there already. So what is your finding in this research?
Sir, next time I try to this other test.
And one more thing, you have chosen the secondary data. Where did you get this data? From
Yes,
where?
sir.
From where
Sir,
you have get this data?
sir, hospitals वगैरह.
Hospital. But you said you have taken the data, secondary data.
Yes, sir.
You have collected the data
Yes, sir. Yes, sir.
individually, or have you used the data given by someone else?
Sir, someone else.
Someone else.
Yes, sir.
Then how will you ensure that that data is because in your also in your test, you please check the calculation once again.
Okay, 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 sir.
I feel something missing is there. And one more
Okay.
thing, fundamental thing I want to know about the chi-square test. In your chi-square test, you have written there degree of freedom is 2. Okay.
जी सर,
And
ठीक है
and what is the meaning of the 5% level of significance?
सर। कैलकुलेटेड वैल्यू अगर काई स्क्वायर की हमारी इससे टैबलेटेड वैल्यू से
No,
लेस
no,
आ रही है
what is the meaning? If you increase the level of significance 10%, then what will happen?
सर, अगर सर इस पर वैल्यू आ रही है तो सिग्निफिकेंट मानी जाएगी कि दोनों में नो
I mean,
रिलेशन।
what is the meaning? What is the meaning of level of significance? 5%, 1%, 10%. I'm not asking the interpretation between the observed value and calculated value.
यस सर, यस।
So what is the meaning of level of significance?
आई नो
General
सर,
question.
प्लीज टेल मी सर।
Okay, there's no problem. Ansul, you please read one fundamental book of the statistics, if
Okay, sir.
possible for you, because there are some you that type the research you are doing in the malaria. Malaria is very important area.
Yes,
Even if you have good idea, you can write to some funding agency. Maybe you will
okay,
get,
okay, sir.
because 2025 government of India has some vision, because they want eliminate the malaria from across the globe.
Okay,
Okay,
sir.
but for this you need some fundamental books or research paper, because
Okay, sir.
that the work you have shown here, it needs some more improvement. Okay,
Okay, okay, sir.
that is
Thank you.
just my suggestion.
Okay, sir.
Okay, thank you very
Thank
much,
you, sir.
Anshu. So now the next presenter is Sonika Sharma. Sonika Sharma, are you there?
Yes, sir. Yes, sir. I am present.
Okay, yeah, yes, please share your screen and present your work. Anshul, are you there right now? Anshul?
Yes, sir. My slides are visible.
Oh, okay, just a minute. Sonika, Anshul is there? Anshul Dubey, are you there? Okay, Dr. Anju asked one question. I have not seen that message. Sorry, madam. Dr. Anju, what size is chosen for the study? Sorry, and then next. Okay, now, Sonika, you can.
Sir, is my slides are visible?
Not visible. Not visible.
Share screen. Now, sir, is it visible?
Yes, now it is.
Okay, sir.
You can start. And Sonika, my request to you, please focus on your main result. Do not
Okay, sir.
elaborate the
Okay, sir.
waste the
Good
time.
afternoon to one and all present here. I am Sonika Sharma, research scholar doing my research under the supervision of Dr. Shipa Sood ma'am. And topic of my presentation is Darcy flow due to silicon oxide, aluminum oxide plus ethylene glycol hybrid nanofluid in the presence of dissipative and radiative flow past event. This is the outline of my presentation. In abstract, in this study, we have taken viscous and radiation impacts with Darcy-Fukushima flow on a two-dimensional boundary layer flow across the stretching wedge. And ethylene glycol is taken as a base fluid, and silicon oxide and aluminum oxides are taken as nanoparticles. We have developed a mathematical framework for simulating hybrid nanofluids physical properties, and employing some similarity techniques, we transfer the nonlinear partial differential equations into ordinary differential equations. And after that, we use MATLAB-based BBP4C solver to find the solution. And the results are depicted through figures and tables. In introduction, first of all, wedge. Wedge is the triangular shaped object which can be used in the process of separating. A wedge converts the lateral lateral force into a transverse splitting force, and they are also used to slightly lift heavy blocks and machinery for making finer alignment. During the last few decades, laminar boundary layer flow past a wedge has been of a considerable interest. Flow, heat, and mass transfer along a wedge has gained considerable attention because of its vast applications in industries and natural processes, technological processes. Boundary layer flow over well-shaped solid are very common in many thermal engineering applications, such as geothermal system, crude oil extraction, groundwater pollution, thermal insulation, and etc. Next one is hybrid nanofluid. Hybrid nanofluids are a new kind of working fluids that is made by a suspension of two different types of nanoparticles having size less than 100 millimeter into the traditional fluid. And this new kind of nanofluid is having higher thermal conductivity and thermophysical properties than the conventional fluids. In recent years, hybrid nanofluids are used in various heat transfer applications such as heat pipes, solar energy, refrigeration, as well as heating or air conditioning. Next is porous medium. A porous medium can be defined as a solid body which contains white spaces or pores that are generally filled with fluid, for example, solids, woods, etc. And fluid flow can only take place in the interconnected pore space of the porous medium, and this is called effective pore space. And there are a number of models that have been derived in the past few decades to elucidate the flow flow passed through the porous medium. The fundamental model to describe the behavior of fluid flow in the porous medium is known as Darcy model. And Darcy model Q dash is equal to minus K upon mu into gradient P, where Q dash is Darcy flux, gradient P is pressure gradient, and mu is viscosity. In 1901, Forshimer discovered that at a sufficient high velocity, the relationship between flow of the fluid and the potential gradient is not linear. This non-linearity increases with the flow rate. And the additional pressure drop due to the inertial losses in primarily due to the acceleration and deceleration effect of the fluid as it travels through the tortuous flow path of the porous medium. The Forshimer equation assumes that Darcy's law is still valid, but that an additional term must be added to account for the increased pressure drop. Hence, the equation is called the Darcy-Forshimer equation. And this is the geometrical representation of our problem. In this problem, we have considered an incompressible two-dimensional boundary layer flow with viscous and radiation effects over a wedge with Darcy-Forshimer flow. We have taken here SiO2 plus Al2O3 with ethylene glycol as a hybrid nanofluid. Here UW is the wedge moving velocity and U infinity is the free stream velocity. TW is the temperature at the wall and T infinity is the ambient fluid temperature. X-axis is taken along the well surface and taken parallel to the well surface, and Y is perpendicular to it. Objectives of our study is to formulate the mathematical models for a two-dimensional Darcy-Forshimer hybrid nanofluid flow with viscous dissipation and radiative effect, and also to investigate the effect of different relevant parameters of the fluid flow, assumptions for velocity and temperature profiles. Methodology, formulation of equation, transforming partial differential equations into ordinary differential equations using similarity transformations, and then numerical analysis by using BPP4C solver, and in last analyzing the result. These are the governing equations. This is first equation of continuity, second is equation of momentum, and this is energy equation. The radiative heat flux under Rosland approximation of the radiation can be written as QR is equal to this, and after differentiate this we will get del Q R upon del Y this value, and we substitute this value in the energy equation, and at last we get this equation of energy, and we used these boundary conditions in our research paper. Using these similarity transformations, we transform the partially differential equations into the ordinary differential equations, and we will get these two equations. And the boundary conditions, after applying the transformations, the boundary conditions are becomes these. And the dimension parameters are beta is equal to 2m upon n plus 1, and beta is the wedge angle. Here beta is the pressure gradient, m is this m is equal to beta upon beta minus 2 is the wedge angle parameter, L is the porosity parameter, Fr is the Forshima number, R is the radiation parameter, Pr is the Prandtl number, and this is Eckert number, and lambda is the constant moving wedge parameter. These are the thermophysical properties and applied models which we use in our research paper. We have done comparison with the earlier published papers for validating our result. Effect of M, Fr and L on velocity and temperature profiles. This graph shows that these factors, the effect of these factors on velocity and temperature profile. In conclusion, a few of our study's most significant findings are the velocity distribution grows for larger value of M, Fr, L, and lambda, and declines for stronger hybrid nanoparticle. The temperature field thickness is higher for lambda 5 and 5 2 and EC, while decreases for higher values of M, Fr, L, R, and PR. And next is the skin friction coefficient rises with the rising amounts of 5 and 5 2 and M. And last is the local Nusselt number shows increasing behavior for increasing amounts of 5 and 5 2 PR, EC, lambda, and R, while decreases for these parameters. These are some references. And thank you.
Okay, thank you. Thank you, Sonika. Is there any question from the audience side? They can ask directly. Is there any question? Okay, and as per the our convener, Dr. Anju Khandelwalji, please turn on your video. That can be taken. Please turn on all. Please, all are requested. Turn on your video camera. Okay. Before that, I just wanted to say that all the presenters are good and they have presented well, and I hope they will also incorporate. If they like, they can improve one or two suggestions. And for this, I would like to thanks on behalf of our colleague Professor Sapna Ratan Shah and myself to Professor Suneet Saxena ji for and Namaskar sir for introducing us in the beginning, and Dr. Anju Khandelwal for inviting us, and Madam is also always energetic and ready and conducting this type of nicely organized, well organized programs. I was I just in 2007, I think, Madam, we came into the contact. 2007, in the conference. That was my first conference that I have attended in SRM college. At that time, I was the research scholar. Also, my thanks to Professor Kamlin. I know sir is very busy always. And thank you very much, sir. And I can also see Dr. Amit also here. Thank you to all. And I just hand overing the mic to our colleague, Dr. Sapna Ratan, if she want to say something. Dr. Sapna?
Yes, thank you so much, Dr. Anju Khandelwal and Kamlesh sir, and all the entire team for organizing this conference and for giving this chance to chair this session. All the participants were wonderful. They have given their nice talk, and definitely we get or the other participant, they will get the benefit of this wonderful research work done by all the participants. So thank you so much.
Now, please, all are requested turn on your video camera. Please. ऐसा तो नहीं खाना खाने लगे सब लोग लंच का टाइम हो रहा है
So I also request all of you, please open your camera.
Yes, please. And open career, and there is a one small announcement to all the participants. In our JNU, we are also conducting a conference in the month of June, 16, 17, 18 June, international conference. You can also participate and send your paper. Date is also still open. We have not closed. Last date is paper submission 16. And madam, please also send your track if you are
Sure, sir. I will send the title of the track soon. Okay.
yes, and the theme for optimization if possible. Otherwise, as per your choice of your
Okay.
area.
Okay, sir. Sure, sir.
So now I think we can take that space.
Thank you, ma'am. Thank you, Kajin sir, for accepting our invitation as a session chair. Thank you to all of you, and thank you all the participants also who joined this session. Thank you.
I request all the participants, please join at 1:50 for next invited talk. You please join at least 10 minutes before. So thank you very much.
And Dr. Saxena, do we need to send the report or for the
Yes.
presentation?
Yes, sir. You can send report by email to Anju ma'am.
Email or I we will share the Google link and we will add to Dr. Anju. Is it okay, ma'am?
Pardon, sir?
We will check.
Sir, I will contact you on the WhatsApp later within a 10 to 15 minutes.
Okay, right.
Okay, sir.
Yes.